Welcome to this talk about making a graphical IDE with Elm and Purescript. I'm Claudia Doppioslash. I'm a game developer and a functional programmer. And you might have read my functional programming articles on LambdaCat, my website. And I work for Stritzinger GmbH, where we make embedded hardware for industrial automation and the automotive industry, which mainly ends up being factories, like conveyor belts and uploading firmware on cars. This is some of the stuff which runs our beam, actually. So we have a beam runtime that runs on the hardware. And this is a video of the conveyor belt working. And we also make embedded hardware. This is a wireless board that runs the Erlang VM. So you can program with any Erlang language on it. And it's got, as I said, wireless. And also it's a real-time operating system on it, so that's bare metal. And I guess there are a bunch of reasons why you might be here. One is that you need to get front-end code done and you hate JavaScript. So who is like that? That's always a good reason. And also you might be interested in Haskell-like languages, and we'll talk a bit about 3 of them today, so that's should be worthwhile. And you might also be undecided on whether to choose Elm or Purescript. Who here is undecided on that? A few. That's good. Hopefully you'll hopefully you have more, you know more about it and be able to make a more informed choice. So what you're getting is a work in progress mortem. We have this project. It's not finished yet, but it has already been going through a bunch of stuff. So I'll talk to you about the choices we made and what went right, what went wrong, and I'll give you an overview of Elm and Purescript, a very quick one, and also of our experience of porting some stuff from Elm to Purescript. So this is not an Elm or Purescript guide, and also it's not about the latest Elm. So it's not about 0.16, it's about 0.17, it's about 0.16, and that is, I guess, an interesting thing to talk about. So the jump between 0.16 and 0.17 removed all the stuff that you see there: functional-active programming, bail boxes, addresses, signals, and fold P. So if you see any of that in the talk, you don't need to know that to do well now. And I'll talk to you later about why all that happened. So the project is a visual IDE for a PLC language. PLC stands for Programmable Logic Controller. And it's sort of a parallel evolution of embedded hardware programming that is used in industrial automation. There you can see a function block, so it's a visual language, so it uses these function blocks, and you can see some of other editors on the other side. To make this editor, we were inspired by Brett Fitter's Inventing on Principle talk, which talks about how to make a better experience for programmers by making interactive editors. So this is our editor. I'm afraid I would have had a demo, but since the computer malfunctioned, this is all you're going to get. I'm sorry. So basically, you see the function blocks on the right, and on the top, there are the events, and they fire in red. And on the bottom of each function block are the variables. So with Area IDE, if you click on the variables, you can get a plot on the other side that shows you the last values of this variable for the last 60 seconds or so, which if your software runs on an embedded hardware, so it's hard to get to it and it's hard to debug it, this should be very helpful for people to make a better programming experience for PLC. So since it's a bit complicated, I'll show you a graph. Our project, so we have the PLC language, people programming this PLC language, their industrial automation stuff, and we have a compiler that takes this PLC language and compiles it to Erlang, but basically beam files. And these beam files run on the hardware. So we have the beam running on the hardware, and also Cowboy is running on the hardware. So Cowboy talks to the runtime of our compiler and our program, and it gives us debugging information we can use in the IDE. The requirements were pretty broad. It had to work on all PLC OSs and also on iPad Pro. So the iPad Pro is powerful, but maybe not that powerful, not as powerful as a PC. And also the performance needed to be interactive because we have those graphs updating in real time. So 30 FPS we thought should be fine. we had a few options to do this, like making native applications for each platform. That would have taken a lot of time and be very expensive. So we chose to use web technologies, so we can be cross-platform. That would mean JavaScript, SVG, and CSS. But we thought a minute and said, do we want to do JavaScript? And the answer is, well, no. Please, let's not do that. It's not bad, but let's not. So the possible choices at the time for a language that compiles to JavaScript that is not JavaScript were ClojureScript, CoffeeScript, Elm, and TypeScript. So by the title of the talk, I guess you can guess what we chose, but reasoning for it is probably interesting. So the main thing we wanted to have was functional reactive programming. Because being an Erlang shop, functional reactive programming is sort of a thing that felt familiar to us, but that is now gone. In 0.17, it's gone. Also, the good error messages were a pro. They're certainly better than undefined is not a function. So that was something very motivating for us. Also, some concepts were similar to Erlang, like mailboxes. So it was familiar. It felt familiar. So what is Elm? You probably already know this, but I'm going to go through it anyway. It's a purely functional, strongly typed, eagerly evaluated language that compiles to JavaScript. It used to have functional reactive programming. It used to be based around it. And it's also got a syntax that's very Haskell-like, but without the squiggles. So you don't have the dollars, you don't have the starship operators or more strange operators. And it's also a very small language, and they try to keep it small. They're very draconian about it, actually. And from 0.17, it's optimized about learning curves. So if you start to learn Elm, you shouldn't find any point where you get properly stuck, hopefully. So it's similar to Haskell, but you don't have type classes, basically. And another nice thing is the elm-package manager enforces semantic versioning, which is a bonus. So compared to JavaScript, the pros were, if it compiles, it works. And I can't say 90% of the time that's the case, unless you're actually deliberately getting rid of some type information. Say if you need to render some SVG, you have numbers before calling the SVG function, but SVG only takes strings. So there you lose your type information, and then if something is wrong, you get a nice runtime error when you run the SVG. So we can be confident of refactoring because of set types, and it's also very clean, and you can get much further with fewer lines of code than you would in JavaScript, and the famous great error messages are plus. So those error messages, they work because they are contextual. So in this case, you have a case, and you're missing one branch to be a total function. So it shows you your bit of code. You don't have to get your editor, get the code, and find the place. It will show you. And it will also correct common errors. So here, the solution is simple. So it tells you what to do, which is helpful. And how they do this, how they achieve these great error messages, the first thing is they make it a priority. So it's really important for the Elm community to have great error messages. So they carefully track them on our Git repository, and people can send their own error messages that weren't clear. So then everyone can look at them and make them better. And another reason why they're able to do this is the type system complexity is not that complex. So it's easier to have good errors if your type system is not that complex. But in my experience, in 0.16, it might be fixed now, I don't know. If you have a big program and you're calling something a bunch of times in different places, if you get the types wrong in one place, it will tell you the definition is wrong. So then you have to fish and for all the places where you used it, which is less than ideal, but it's not a big thing. And if you've seen the WAD talk, you will probably agree that Elm actually makes sense compared to JavaScript. For example, this is what used to happen in JavaScript. If you did array 16, you get 16 commas. So Elm actually makes sense. It doesn't do that. So there are also cons compared to JavaScript. The JavaScript interoperability is a bit inflexible. It's a bit more flexible in 0.17. but it's done that way. I mean, it's a conscious choice, so it's going to likely stay that way. And it's also a new language, which is 0.x, so there are going to be changes, and they might be big. But all in all, it's not that much. So that was an easy choice. So our project, we're back to the PLC board. There is the beam running on it. There is the PLC program running on it. And then we have Cowboy and Bullet running on the same beam, and they talk to each other. And through WebSocket, they talk to the browser, which is running the Bullet client library, which through Elm ports, is talking to our WebSocket library, which is called Elmrang. And we have a WebSocket library because at the time, Elm didn't have WebSockets. And it's basically a wrapper of Bullet. And to Elmrang gets the JSON from the WebSockets and gives them to our PLC IDE. So later on, I'll show you another graph about the PLC IDE. I was supposed to have demo here, but no. I hope you remember the image from before. So the PLC IDE structure is, so we have the PLC device, where we just saw what happens on that, and we have a WebSocket library, which is a component, and we'll talk about later what is a component in this. And then it gets the JSON messages to another component, which is the decoder. The decoder sends them to the renderer, which keeps all the state in the app and also renders it to the browser. And then UI interaction is sent to the encoder, which is another component, which sends it back to the WebSocket library, and it gets back to the PLC device. So for example, I could open a variable pass states from the web browser just by clicking on it, and this whole communication goes on. So each one of these components is a startup. A startup is a concept that was in 0.16, which is basically a library that implements the Elm architecture. And the names, you're probably familiar with the Elm architecture, but the names are a bit different in 0.16, so I'm going through it very quickly. And beware, this is not how it works in 0.17. So we have an action, which is a union type, and it's just anything you can do in your app. So if we have a counter, you can only have increment or decrement. Then there is the model, which can be any data type that you want, but here is just an int because it's a counter. And then we have the update function, which takes an action and the model and gives you back the other model. So we have increment, model +1, decrement, model -1. And then you have the view that is passed, the new model is passed to the view. Ignore the address here because that's 0.16. It's not like that anymore. But so it takes the model and gives you back the HTML that you can render. So in this PLC IDE, we have those components are actually startups, and they're wired by mailboxes together. And then we put them into a bigger startup, and then we wire that into the main. So that's how everything gets wired up. This structure was invented by a GitHub user called Fox Donuts. And we used it because it's easy to expand, it's easy to add new components, and the effects from one component, if you have effects on one component, you don't necessarily need to have effects in another component. But no one ported this to 0.17 because it was signals and fault peas all over the place, mailboxes, a lot of them. So it might be impossible, it might not be impossible, it's surely not trivial. And our WebSocket library can be a component using this structure. We were supposed to open source it, but then it's not really relevant anymore, so we didn't. So why are we still on 0.16? So as I said, we use FRP very heavily. And also this project was for a client, so we cannot use an unknown number of weeks of money from the client to port this because we're not guaranteed to have a result. And also it works. So if it works, don't touch it. It's cheaper. And we were also frustrated with lack of communication because from 0.16 to 0.17, there were 6 months. And in those 6 months, it would have been nice to have a deprecation warning instead of just finding out on the 0.17 alpha day that everything was gone. It was a bit of a trauma. So we're waiting for the Elm evolution to stabilize, maybe come back in 1.0 or slightly earlier to see, so we know what we're getting pretty much. There was a bunch of production problems to get Erlang working with Elm, which are not big problems, but it's probably interesting to look at them anyway. So the main one is how to organize subcomponents in a big Elm app, and that is a big topic in itself, and I think it's still an odd one at the moment. And also how to store dependencies which cannot be on elm-package because elm-package doesn't accept JavaScript files. So your libraries have to be completely in Elm. And also how to include Elm projects inside an Erlang app. So my solution for components is this, and I got it from the structure that I talked about before. So action model and view and update, I have each own their own file, which you might not need if you don't have that much code. But once the app gets bigger, it's pretty useful. And also there is a feature file, which may be a bit strange. You might not have seen it, and that's from that structure I talked about before. So in the feature file, you wire up all the mailboxes, so you can build your component. And then in the app file, we wire up those mailboxes into a bigger one, and then we wire that component into the main, because the main takes an init, an update, and a view functions, you might remember. So there needs to be one point to wire everything up. About having dependencies which are not on elm-package, it's not hard, but it can be a bit tricky, so this is how we did it. So we have our own repository, and we store it in a subdirectory of the Erlang project. So we had Elm, it's a subdirectory of the Erlang project. We only move the Elm files to a subdirectory of the Elm project, which shouldn't be under Elm stuff directory, because that's where the Elm package puts their own stuff, and you don't want to mess with that. And then we include the subdirectory into the elm-package.json, so the Elm compiler knows how to look for the files, and that works. And also, a slightly more interesting problem is how to mix Elm and Erlang project. We could have done it in a number of ways, but what we wanted to do was to have Erlang projects that have their own Elm apps. So in the end, instead of having different repositories, it was easier to just have a subdirectory inside the Erlang project. And then we compile the Elm files to the priv directory, which is where Cowboy gets their static files to serve. And then we just add the JavaScript file to the HTML file, and that works. About rendering. So this is an interactive application, so rendering needed to be decently fast. There were a bunch of choices. The first one was to do a WebGL 2D rendering engine, which would have been great. I would have loved that, but we didn't really need to do it, sadly. Another choice is to just use HTML, which well, it's less than ideal. And the other choice is to use SVGs, with or without CSS, layout, and animations. So in the end, we use SVG with CSS, as much CSS as possible, because ideally, you wouldn't want to do too much animation with Elm, because keeping the animation state around is awkward and inconvenient, although there are good animation libraries for Elm if you want to do that. So we have an expert, an SVG and CSS expert on call, so we don't have to know anything about SVG or CSS, because so many things can go wrong with that. So this person just does her magic. She produces the CSS files, and those are separate files, and I get to write by hand inside the Elm file, the code to generate the SVG files, as she said. One note about that is that I think that Elm HTML and Elm SVG, which are the two libraries that you can use in Elm to generate SVG and HTML, have great syntax, because, for example, here is, you can have the tag name, and then you pass it to lists. The first list is for attributes. The second list is for the tags that are inside that tag. And it might remind you of Hiccup on Clojure. I think it's very elegant as it can be without being a Lisp. And it's also based on virtual DOM, which is fast. And you might have seen around benchmarks on how fast Elm is. And I think they're pretty nice. That gets a good rep about that. So, closing on our Elm section, I think if you want to use Elm for your project, there are a few things you should know about. So the first thing is be aware of what Elm is good for, because Elm is very opinionated. And if you do use the case that it's optimized for, then your sailing is smooth and everything works for you. But if you're butting heads against Elm, it will fight back. So it will be hard. So probably you don't want to use it for stuff that doesn't fit the Elm architecture. So take a good look at it and see if your project fits with it. Also, if you want to wrap big JavaScript libraries, yeah, you probably don't want to do that in Elm unless you're really into ports, because you have to make everything pass through the ports. Also, you can't get them into elm-package. It's actually easier to get Elm inside React than it is to get React inside Elm. And I think on the Elm website, there is a way to do that, to get Elm inside React as a component. Also, Elm is still experimental, subject to big changes, so be ready to rewrite some code. And correlated to that is Elm lacks a roadmap. It's all in Evan's mind, and we're not quite private with what goes on in it. We're more private now because it does share with the mailing list, the Elm dev mailing list, what he's thinking about. So at least you know what's going on in his mind and what he's working on. But between 0.16 and 0.17, you could only know that by checking out the commits on the Elm compiler repository, which I didn't do. So what next? We're going to skip 0.17, probably 0.10, and maybe come back when Elm is nearer to 1.0, or at least when we are reasonably sure we know what we are getting. Meanwhile, we are on the market for another compiled to JavaScript language. So we might port a portion of our project and make new projects with them. So more choices. They are breeding like rabbits. So there is Reason now, there is Bucklescript, there is Fable, and there is Purescript. And I think you know which one we went with. So we have to choose wisely. We try. So our first choice was Elm. It was very cute. It told us, please adopt me. I won't mention monads. Everything will be easy. And it was very convincing. And our second choice is Purescript. And Purescript basically says, you're free to do everything as long as you can make it compile, which is very freeing after having worked with a very opinionated language that says, you should do this as I say, and not anything else. So Purescript is a purely functional, strongly typed, eagerly evaluated, and compiles to JavaScript language. Does it remind you of anything? So with that, we were fairly sure we were continuing in an evolutionary way in our road. Oops. And so it also has advanced types, like monoids, type classes, monads, that sort of stuff. The Haskell-like syntax is really Haskell-like. You get all the squiggles, spaceship operators, all the fun stuff. And it generates readable JavaScript. And differently from Elm, it doesn't have a runtime. So at the end, it's all, if you read the code, you don't have to figure out what the runtime does because there is no runtime. Also, a nice thing is that it's got an open community and a bit of a roadmap, which is basically we get to Haskell-like parity, I guess, with time. So philosophy differences. In Elm, everything is made to be simple. The choices are made for you, which gets you started way quicker because you don't have to make any choices. This is the way it is. Go ahead and do it. In Purescript, you have most of the type features from Haskell, and so you have a longer learning curve, and you have to make a bunch more choices. Also, in Elm, you can have only one possible program structure, which is the Elm architecture, while in Purescript, you can have many possible ways of structuring your app. You can just make them up from scratch if you want. So why Purescript after Elm? Well, I thought the type system in Elm was very good. It was a nice change from doing C# or JavaScript or a bunch of other stuff. I'm originally a Lisper, so type systems, well, they're not totally new for me, but a strongly functional type system is. So I liked it. I'm convinced. So we take a good thing, which is the Elm type system, and we give it more features. Now, for those more features, so we get more power, but we have less simplicity, so trade-offs. So the simpler types gets you a small learning curve, a smooth learning curve, and a more boilerplate. Because you have to, what the abstraction gives you is that you can abstract away the stuff that repeats. So if you don't do that, you end up repeating the stuff. So you get more boilerplate. And I think those of you who went to Jessica Kerr's talk, so another way to deal with that boilerplate stuff. So also, it's similar enough that I don't have to write everything from scratch. If we had used ClojureScript, I would just have to write a whole lot more parentheses, which I would have liked. But this way is also good because I get to copy and paste my types and try to make them work in Purescript, which gives you something to start with. And also for this, it's very good, the Purescript Elm library, and also the talk that Ryan Lemple did. You can find it online on YouTube. So the Purescript Elm library is a compatibility layer. So you can basically take your Elm code, change a little bit of syntax, and run it. Now, I don't think it has implemented everything, so there are limits, but you can still look at the code and see what it did. So you don't have to find out yourself how to do a dictionary in Purescript. You can just look at the dictionary file in Purescript Elm, and you can read from that, which saves a lot of time. So I got restless with Elm's boilerplate. By the 30th time you make a subfunction to your update function, it gets old. So I'm ready for more powerful abstractions, even if I have to spend a bunch of time learning them. So that's good for me. Also, it's possible to implement Elm in Purescript. As I just said, you have the Purescript Elm library, but it's not possible to implement Purescript in Elm, at least not at the moment, because you have the Elm architecture, and that's not very good for implementing other languages, I wouldn't think. It also benefits from the insight of following Haskell from a distance. So Haskell does the research stuff, and then Purescript, when they finish with it and they made it nicer, Purescript comes around and says, oh, we'll do that right the first time around. So they don't have to go back and review stuff quite as much. Also, the community is very nice. Elm's community really grew, which is a good thing, but it also makes it more difficult to communicate. And when your Slack gets to 30,000 people, it gets a bit crazy. On the other hand, the Purescript community is nice and small, and you still can know pretty much everyone, probably. But not quite, but still. There are video meetups, online meetups, so you can talk with people, actually. And the channel is very nice, the Freenode channel. And there is also a Gitter and a Slack. So there are also some outright pros, I think, compared to Elm, which one is PureSuite, which is basically Google for Purescript. So PureSuite has got all the code from all the Purescript libraries, and you can search within that by type signature, which I think is great. And also you can search from strings or anything. And it really helps. I think Elm also has got something like that someone else implemented. But yeah, you'd have to find that out. Also, it's got a clear direction, as I said, so I sort of know what I'm expecting. And I found that I can work a lot more with the REPL. Because in Elm, you have all the wiring up and the runtime, so the REPL doesn't. It's a bit harder to work with the REPL, while in Purescript, if you import the libraries or the code you made, you can just build your program in the REPL, I find, if your program is easy. At least I use it a lot more. There are also type holes, which are getting even better now. And if you saw the Space Monads talk, you know how type holes are awesome. And while you have many of the cool abstractions that are around, the cons are, it takes time to learn the cool abstractions, so book some time to learn them. Now I'm going to inflict on you a reflection on how Elm and Purescript and Haskell relate to each other. I'm sorry. So Haskell is a research language, which means all the cool stuff comes to Haskell first. But that cool stuff is very new, so they haven't thought about user experience yet. So it's quite hard to make it work for you sometimes. While in Purescript, they take the cool stuff and they wait until they figured out a nice way to do it, and they implement it, which makes it easier to work with. Also, but in Elm, you have the simplest language. They're not only worried, but one of the main things about Elm is user experience. So they really, really worry about that, and sometimes things are just made to make the user experience better. So that's one big difference, I think. And in Haskell, you have all the ways to do things, and people are making up ways all the time. In Purescript, you are still free to do anything, but you don't have the research going on in Purescript, I don't think, at the moment. But in Elm, you have only one way to do things, which is Evan's way. And which is good. He has got great design sense, but still you have to agree with him on everything. And another thing is that Elm is draconian about removing historical baggage. So even in the next version, they're going to remove some stuff, which doesn't really happen in Haskell quite as swiftly or at all, possibly, because I don't think it's quite easy to turn GSC around and change stuff. There are many people to make agree with you, and it's not quite that easy. But also, they're not probably worrying that much about it. And in Purescript, they also remove stuff, but they are less draconian about it. They will leave some stuff around that not everyone uses. And so I think, in the end, Elm is a great beginner language into Haskell-like languages because you learn the syntax, you learn purity, you get used to let and in and that sort of stuff. So you have that with the least cognitive effort needed to actually do stuff. So you learn that and you make something, and you will get something done relatively quickly. You can make a small project without going crazy. When you are tired about boilerplate or you want to try out other ways to do things, you can move to Purescript, which has got a lot of the gray stuff that's in Haskell, but it also it also gets it right the first time because they come after Haskell enough to know what the right way to do things is. So you add more types, type classes, monoids, monads, and all of that. And you can still get started relatively quickly, especially if you've done Elm first. And at the end, you can go to Haskell, where you add laziness and you add dealing with pragmas and that sort of stuff, which might be complicated, but it also gives you a lot of power, which you may need. So that's my view of this matter. I know people go straight to Haskell. I wouldn't do that. I tried. This way works better for me. So I hope I made you want to try Purescript. And if you try Purescript, please be aware that the new version has landed, and when a new version lands, usually the Purescript by example book is on the version before it. So don't just install 0.10 and expect everything to work straight away. At one point, the porting will be complete, so then you will be fine. But for now, I say stick to 0.9.3, so everything can work for you. And one point of contention is Bower. Well, with Bower, it doesn't really have a notion of where Purescript is at. So even if you have 0.9.3 installed, it will still try to install the latest libraries, which are for 0.10. So if you're on 0.3, watch out and check what Bower is installing, because it may be hard to get a set of libraries that just works if you just let Bower do its thing. But the good thing is that Phil is working on a new package manager, so I look very much forward to that. And as an aside, I would say, please, let's not try as an industry, let's try not put our dependencies on GitHub anymore. It's a single point of failure, it times out, it's painful with Bower. Please, let's try not to do that anymore. So I'll give you a short frameworks overview. There are basically two types of frameworks. One type is wrapper in React, and the other type is in Purescript. So the type complexity sort of works like this. At the very beginning, there is Flare, which is a pretty cool library to make interactive graphs. And I started with that. It doesn't require a lot of type complexity, and it's a really nice way to start, I think. Then there is Pux, which is basically the Elm architecture, and it wraps React. And then there are here be lenses, there are termite and optic UI, and here be free monads, there is Halogen. So as I said, for Flare, it's a great way to start with, and you can make really nice interactive graphs with it. You might not want to use it if you want to do a web application from like a proper single-page web app, because it doesn't do that. But the good thing about it is you only need to understand applicative functor syntax, and not much more than that. So that's basically applicative functor syntax. It's easier than it looks, but you have to go through all the steps to figure it out. And then there is Pux, which I think is a great way to port an Elm architecture app you might have, because it's very similar to the Elm architecture. And you can also have the interactive React debugger wired in, which brings back the time-traveling debugger from Elm, basically, which is coming back, but still, you can have it now. It's also probably the simplest Purescript framework. One reason not to do that is React dependencies, getting React dependencies. And since I spent a few days trying to get Power to and NPM to work with me and not time out on GitHub, and since the starting app is a repository you can clone from GitHub, and that gives you a nice setup with Pux and React and gives you the interactive debugger, but then every time you try to install it, if it fails, it just starts from scratch. And it's like banging your head against a wall, so I wouldn't do that, but anyway. So Pux Structure, I said, is very similar to the Elm architecture, and I'll prove it. And this is 0.16, as you can see, the names are basically the same. So below is the Elm architecture, and up is Pux. Model is state, action is action, update is update, and view is view. You even have inputs. But the only thing that's different is basically in Elm you have effects. And in Purescript you have to deal with Purescript effects, which are called F and AF. And this is some code that is a Pux app. And it probably reminds you of an Elm app. So next, Termite and Optic UI. Termite wraps React, and Optic UI is just Purescript. And Derby lenses, and I'm afraid I can help you with that. Talk with Phil, who is making Termite. He'll know way more than me about it. And next, I'll talk about Halogen. So if you'd rather not install 300 React tools and spend your life on Bower and NPM, you can use Halogen. It just installs straight away. It's used in production at a company called SlamData, and the app they are making with it, I think, is fairly impressive. And an advantage of that is, since they are using it in production, there are a bunch of people developing it all the time and keeping it up to date with the Purescript changes and also making it better. And it has a nice HTML DSL, which, coming from Elm, is an important thing to me. You might not want to do that because they're not holding back on the types. So you might want to have finished the Purescript by example book before doing that. But I think it's a very good thing to have, Halogen. It still looks a little bit like the Elm architecture. Model is state, action is contained into query, query contains action and request. Request is a way to ask something out of a component. Component has its own type, which is probably a good idea, I think. Update is a val, and render is view, and view is render. And inputs and effects can be wired into the main. And this is not all the code for an Halogen app, but enough to get the idea of how it looks like. So getting started with Purescript, my suggestion is get it from NPM or PSVM, because then you get the version you want. You can get 0.9.3. If you just get it from your operating system package manager, it will probably give you 0.10. And then if you can't install stuff, don't blame me. And then you should start reading Purescript by example, which is I really like that book. I used it with some Haskell documentation to learn. And if you already know Haskell, you probably will skip through that like a breeze. But I don't know that much Haskell, so I needed some extra stuff. And then I suggest you look at the Purescript Elm compatibility library, because it tells you what everything in Elm is in Purescript. And then you should probably try out Pux or Flare. Flare is really fun. That's the first thing I did, and I really liked it. And then coming out on Purescript or on Freenode, even earlier than that, which is a really nice place. Come to the video meetup, and then maybe you could try Halogen, and then profit, possibly. So the conclusion about Purescript is powerful, and it is also sensible. It's got all your favorite abstraction, possibly some you didn't, which are not your favorite. And it will take some time to learn, but knowing Elm, you get a head start. And also, you don't have to know everything to start with. You don't have to finish the Purescript by example book. You can start with Pux or with Flare and get the hang of it without learning everything. It's also not obsessed about language UX, but it's still good. They're not doing random stuff. It's good language UX, I believe. So if you were dozing off, I might inflict on you an extra summary. So Elm works fine with Erlang. If Elm compiles, it works most of the time. Boilerplate gets annoying after a while, and you should never expect fancy type from them. Then they're never going to do that. Don't expect type classes. And it's Haskell syntax with less squiggles. And I think it's a great beginner language if you want to get into Haskell later on. And the unexpected removal of FRP for us was a bummer. Also, Purescript works fine with Erlang. And if you compile it works. Types will get complicated if you get into Halogen and that sort of stuff. And you should expect to spend a little bit more time learning it. But I think it's very rewarding, and you do feel quite powerful, like a genie out of the bottle, of the lamp. And you get all the squiggly glory of Haskell syntax. And also, they have a sort of a roadmap, and you can talk with Phil about the roadmap, and he will answer you, and you can get up to date fairly easily. So it's a great second step, getting towards Haskell, and maybe use Pux or Flare to start with. That is all. You're now free to go unless you have questions. And by the way, if you like the embedded board I showed you earlier, you can get one for free from the raffle. There is a raffle. There's another raffle.